In this video, we're going to go through all the lab calculations, so we can go through learning how to calculate millimoles, equivalents, and percent yield, so we can complete all our labs in the future and refresh your memory on all those calculations from general chemistry. All right, so here's the lab that I gave you. We're going to start out by looking at compound A. Right? So I could see from the experimental conditions to a cooled solution of A, and there's 4 grams of it. So I'm starting out with 4.000 grams of compound A. Well, I have grams. I can't do anything with grams other than fill in that mass in the table right there. The molecular weight I get from ChemDraw, so this 221.28 I could fit right here in the table for compound A. I need to calculate the millimoles and eventually calculate the number equivalents of that. So I'm going to go through the calculation for the number of millimoles. So grams to moles, I need the molar mass. So for every 1 mole of A, there's 221.26 grams of A. So grams of A cancel out, and I've converted it to millimoles, to moles. We need to convert to millimoles. Just most of the time, the mole is actually still a large quantity of material, and most of the amounts that we're going to be using in this lab are going to be on the millimole scale, much smaller. Okay, and that conversion, there is 1,000 millimoles for every 1 mole. And then the moles will cancel out, and I'll wind up with an answer in millimoles. So if you crunch the numbers, you should wind up with 18.08 millimoles of A, and this number is going to go right here into the table. We'll figure out the number of equivalents a little bit later on. I need to do the same thing for B. So according to the report, there is 4. Do it in another color. So there's 4.352 grams of B. I'll use the molar mass to convert it again. Again, that number, the mass number, will fit in right here. The molar mass, which I'm going to write down right now, I can get from ChemDraw. That'll go right there. And we're working on calculating the number of millimoles right here. So for every 1 mole of B, there is 240.70 grams of B. And then again, I have to convert to millimoles for every 1 mole. And when I crunch the numbers, I wind up with the same number. So 18.08 millimoles of B. And that number will go right in here in the table. All right, let's look at the next one. T-butoxide, potassium T-butoxide. So the information that I'm given, I'm using 39.77 milliliters. That equals the volume, right? So that amount I could put in right here for the T-butoxide on the volume. And I also know that from reading it that it's a 1.00 molar solution. That's the concentration. And that number, that 1.00 molar, I'll put right over here in the table. All right. And if you remember from general chemistry, hopefully you do, that concentration, molarity, is given in moles per liter. So this is 1.00 molar, which equals 1.00 moles per liter, or it equals 1.00 millimoles per milliliter. Okay? And this is the conversion factor that I'm going to use to convert that. So if I take the volume times the concentration that's going to equal the number of moles, N, in millimoles. And that's what we're going to do. I'm going to take my 39.77 milliliters, and I'm going to multiply it by my concentration, which is 1.00 millimoles per milliliter. And I am going to get 39.77 millimoles of the potassium T-butoxide solution. And that number I'm going to put right up here. We don't need the density for this, and we're going to calculate the equivalence soon. The mass we also don't need, and we don't need the molecular weight because we're using a solution with a known concentration. The tetrahydrofuran, I'm just going to put that in. It says that there's 40 milliliters of THF in this reaction. So the volume of THF, that 40 milliliters, will just go right there in the table. It's not a reagent in the reaction, so I don't need equivalence or concentration. And if you find the density and include it, that's great. That's more information, but we don't need to calculate millimoles or mass or anything from that, or even the molecular weight's not really relevant for what we're doing with it. Okay, so now we got to move on to the acetic acid. When we work up this reaction, we quench it using acetic acid, and we're using 2 milliliters of acetic acid. I'm going to count this as 2.0. I want 2 sig figs for this calculation. So this equals the volume of acetic acid that we use. And acetic acid, I'll just put that volume right in here. I'll put my 2.0 milliliters right in there. So again, I need to do some work. I need to know what the structure of acetic acid is. And acetic acid is this. And if I calculate from that structure the molecular weight, there's 60.05 grams per 1 mole. All right, so that's the molar mass. And I have to look up the density of that material. I'm given a volume. I need to be able to convert that to grams. And if you go online, you'll find out that the density of acetic acid equals 1.049 grams per milliliter. All right, so what I'm going to do is I'm going to use the density, I'm going to use the molar mass, and I'm going to use the volume that I start with to calculate the number of millimoles of acetic acid. So I'm starting out with my 2.0 milliliters of acetic acid, and I'm going to use the density to get rid of milliliters and convert that to grams, right? So 1.049 grams per every 1 milliliter. So I could see that the milliliters are going to cancel out for this one. Now I could cancel out the grams and convert it to moles. So there is, for every 1 mole, there is 60.05 grams. And I need to convert that to millimoles to make it comparable to all the other units that we're talking about. For every 1 mole, there's 1,000 millimoles. And if I crunch the numbers, you should wind up with 35 millimoles of acetic acid. And that number will go right up in here for the millimoles of acetic acid. Okay. You could put the mass in. You could stop this calculation here and put the mass in. Not necessary since we're dealing with the volume. And obviously you're going to put the molar mass that we calculated, the 60.05, right there in that. All right, and as well as the density that we looked up. You should list a reference for where you found the density in your lab report. Any number that you use that you get from somewhere should have a reference with it. So include the reference for your density calculation. All right, so now what we got to do is we need to calculate the number of equivalents and fill out this part of the table. All right, so let's do that. All right, so let's go back. For A, we had 18.08 millimoles. For B, we also had 18.08 millimoles. For the T-butoxide, potassium T-butoxide, we had 39.77 millimoles. And for the acetic acid, I'll just draw out the structure of acetic acid, we had 35 millimoles. All right, so now I need to figure out equivalence. I just take my smallest number, which is the 18.08, and divide it into every other number. So for the equivalence, I'll take my 18.08 and divide it by the 18.08 for A. That's going to give me one equivalent. And that's what I'm going to put in for A. So one equivalent. I'm going to get the same exact answer for B. One equivalent. Show the calculation. That's the one equivalent. For the T-butoxide, I'll take my 39.77 divided by the 18.08, and that is going to give me 2.2 equivalents. And I'll put that up there for the T-butoxide, 2.2. And my final one, I'll do it up top here for the acetic acid. So for the acetic acid, I ran out of room on the bottom, sorry. I'm going to take my 35 millimoles and divide it by 18.08 millimoles. And that's going to give me 1.9 equivalents. And that's the number that I'll put in here for 0.9 equivalents. All right, awesome. Now we're ready to calculate the theoretical yield, which is going to be based on our limiting reagent. I could choose A or B as the limiting reagent because they have the same exact number of moles, so it really doesn't matter. So let's go through that calculation. So if I look at this, for every 1 mole of A or B, I'm going to make 1 mole of the final product. All right? So from ChemDraw, for the product, the molecular weight, I could fill that in where it belongs. So there's 425.50. I could put in for the molar mass. The number of millimoles, right, that I should get theoretically is going to be the 18 millimoles. Let's actually do that calculation. 18.08 millimoles of A. And for every 1 millimole of A, I get 1 millimole of product. So that's going to equal 18.08 millimoles of product. So again, for the number of millimoles of the product, the theoretical amount is 18.08, right? Because that's what I should get. So let's take this calculation a step further. I want to calculate how much product in mass I should make. So again, I'm going to start with my 18.08 millimoles of A. I'm going to relate that to the product. For every 1 millimole of the product, there's 1 millimole of A. It's the same calculation as above, but I'm going to add the conversion to grams here and the mole calculation. All right, so first thing I got to do is I got to get out millimoles because my molar mass is in moles. So for every 1 mole, there's 1,000 millimoles. So I'm getting rid of the millimoles there. And then I'm multiplying that by the molar mass, 425.50 grams for every 1 mole of product. Okay? And what that's going to give me, this is how much product I should make. And if I crunch these numbers, you should wind up with 7.693 grams of product. And that's the number that's going to go right here. That's my theoretical yield for that. All right, so after I get the theoretical yield, I realize that I only make 6.72 grams of the final product. That's my experimental mass of it. So that's the number, the 6.72 grams, that's going to go right here. And now I need to figure out what my percent yield is. All right? So your percent yield, I'll write it across the top, your percent yield equals your experimental divided by your theoretical times 100. So let's use those numbers. My experimental yield is my 6.72 grams. My theoretical number of grams is my 7.693 grams times 100. And I could see that my percent yield is going to turn out to be 87.4% yield of my final product. All right? And that's all the calculations. Hopefully you were able to follow that. And what you should just do is write down on the bottom for here, we're going to include in all these, we're going to fill in the information. So for A, inside the parentheses, I'm going to have 4.000 grams. I'm going to write 18.08 millimoles, and I'm going to have 1 equivalent. So I'm going to show all that information in the text. I'll do the same thing for B. I could also include equivalents with my THF number and acetic acid number. I could write down the number of equivalents that there are with it. And I could also include in this my percent yield. So instead of just saying 6.72 in parentheses, I'll write the 6.72 grams, which is 87.4%. Okay, hope that helps everybody complete the lab.